Use the function f at right to answer the following questions. So this function is a piecewise graph. This 3 means it's a horizontal line at 3, left of 2, and we know it's a upward moving line right of 2. So I want to know, does the limit of f of x as x approaches 2 exist? For the limit to exist at that point, we have to see the limit from both sides. So let's think here. Is the limit as x approaches 2 from the negative side of f of x equal to the limit as x approaches 2 from the positive side of f of x? And that's what we want to see here. Well, what is it getting from the left side of 2? Well, it's always 3. So the left side is always going to be 3. All right. What is it on the right side? Well, to get the right side, you simply plug in 2. All right, so when you plug in 2, 2 times 2 is 4. 4 minus 1 is 3. So we got, again, 2 times 2 minus 1. What is that? Are these equal? Again, yes, this is 3. So yes, since these are equal, since the right side, so we end up with 3 equals 3. So yes, the answer is yes. It does have a limit. The limit does exist there because the left side and the right side approach the same spot. Next, is f continuous at x equals 2? For a graph to be continuous, there's 2 stipulations. We first have to find the value at 2. So what is f of 2? What is the value of f of 2? Well, for which one do we plug in? This is or equal to, so we're going to plug 2 into this one, which would just be 3. So the value at 2 is 3, and we also got to check the limit, which we just did. The limit as x approaches 2 of f of x equals 3. We just did that. So does the value equal the limit? Yes, those are equal. These are equal to each other. So yes, it is continuous at 2 by the definition of continuity. Next, is f differentiable at x equals 2? Well, that's a little bit more tricky because we have to think back to when is a graph not differentiable? And we haven't learned how to take derivatives quite yet. Well, when a graph is not differentiable, the one we're thinking about on this one is, well, the issue we're going to look for is, what you know is the graph is horizontal, and then at 2, it's going to be going up like that. So at 2, right here, it's going up, where it was flat because of 3, and then it goes up right here. So yes, there is a value there. Yes, it's continuous there, but is that jagged edge, that sharp edge, is that differentiable? No, because the slope is 3 here, and the slope here is 2. The slope here is not 3. The slope here is 0, and the slope here is 2. Remember, the slope of this is 0. It's flat. The slope here is 2. So those are not equivalent, so it's not differentiable. So the answer here would be no. It is not differentiable because the slopes on each are not the same. We have this sharp edge, which is a non-differentiable spot. Next, what is f prime 1? So what is the slope at 1? Well, let's think about this. Where is 1? Which interval does 1 exist in? And 1 exists less of 2. So here's the value function, is 3. So what's the slope there? Well, at 3, isn't that a flat line, like I said right here? And what's the slope of a flat line? The slope is 0. So the slope is 0. That's all we're asking for. Just kind of thinking big picture. What would be f prime of like 5? Well, 5's on this interval, so all you do is you look at this graph. What's the slope at 5? Well, this is a graph. The slope is always 2. This line is linear. So this would be 2 if it was f prime 5, if that's what they're asking for. All right, next. Now, this one right here, what is the limit as x approaches 3? Well, a limit as x approaches 3 is basically, the first thing you always do is just plug it in. So can we actually just plug in 3? Can we just basically find f of 3? And if we do that, doesn't it mean this one right here, 3 is on this interval, so don't we simply plug in 3 to this function? So what we have here is we would have 2 times 3 minus 1. And what does that give us? Well, that would give us 6 minus 1, which is 5. So the limit of f of x as x approaches 3 is just 5. We don't even have to do anything special. We just plug it in. Remember, whenever you find a limit, the first thing you do is simply plug it in, because if that's the answer, that's what you're approaching from both sides. Hope this helped.